This lesson is an introduction to proportional reasoning. In 7th grade math, proportional reasoning is going to be probably the most important thing that you learn the whole entire year. This is not to make anything else less important, but everything that we've learned up until this point has to do with this, and everything we do after this is going to use this. So I want you to imagine really long story problems with proportional reasoning, ratios, equivalent ratios, finding unknown values. It all comes down to this. This is the big guns here. This is big time. So pay close attention. Please watch attentively. And here we go. Let's talk about this first example here. For every 2 dogs in the SPCA, there are 3 cats. Now that's a ratio, okay? We could say that that's 2 to 3 or 2 to 3. For every 2 dogs, there are 3 cats. So I can set that up in a ratio table. So dogs to cats, I have 2 and 3. If I go by 2s here, if I multiply by 2s, for every 4 dogs, there are 6 cats. For every 6 dogs, there are 9 cats. For every 8 dogs, there are 12 cats. It's important to note here that it doesn't multiply by 2 every time. If it did, this would be 2, 4, 8, 16, etc. But it's counting by 2s, so the multiplication between each quantity is going to change, and I've tried to note that for you. You can see that in this ratio table from 2 to 4 is multiplied by 2, so that's how we get 6 cats if there are 4 dogs. But if we only knew that there were 6 dogs for every 9 cats, then how do you get from 6 to 8? Well, that's times 1 1/3. And also 12 cats is going to be 9 times 1 1/3. So we're still maintaining that ratio there, okay, that multiplicative relationship. I make note here that we can use a ratio box to determine unknown values in a proportion. And so you can consider this part of the chart a ratio box, right? 6 times 1 1/3 is 8. If you don't quite believe me, I'll go ahead and show you here. 6 times 1 1/3, well, that's going to be 4/3. So 6 over 1 times 4/3 is 24/3. Remember that a fraction is an unsimplified division problem, so 24/3 is equal to 8, okay? Same thing would hold true for 9 times 1 1/3, we would get 12, all right? So a proportion is an equation. This is super important. It's not just 2 fractions, it's not just 2 ratios, okay? It's 2 ratios that equal each other. They are equivalent. Therefore, they are written with an equation. And what makes an equation, the equal sign. So in order to be a proportion, you must be 2 ratios in an equation set equal to each other. So an example of a proportion would be 1/2 is equal to 2/4. It's very basic, but this is a proportion. 1/2 is equal to 2/4. They are equivalent values, 1 to 2, 2 to 4. So there you go. That is a proportion. Okay? So we're going to work with this 2 dogs to 3 cats scenario on quite a few of these boards. Just try to follow along and work through it with me. Notice I've got a lot of blank space here. It's going to be important for you to follow along. So if the ratio remains 2 dogs to every 3 cats, about how many dogs would you expect if there are 18 cats? So I've gone ahead and I've set up my ratio box. Dogs to cats, well, there are 2 dogs for every 3 cats. I don't know how many dogs, but I know that I have 18 cats. If this is an unknown value, I would put a variable there. For the sake of this problem, it's dogs. I don't know the number of dogs, so I'm going to make it the variable D. Remember that as I move vertically, I am multiplicative. As I move horizontally, I am multiplicative in nature. So, I don't really know yet what I'm going to work with, but I've already set these up for you. Okay, eventually you are going to have to find the relationships yourself. But the first first one I notice is that moving from 3 to 18, I am very familiar with 3 times 6 equals 18. So I can do 2 times 6 equals D. And so I will. I'll say, well, 2 times 6 is going to equal D. Therefore, 2 times 6 equals 12. So I know that the answer to this unknown value in my proportion is D. And my proportion, if I wrote it as a proportion, now these are two ratios in a box, but it would look like 2 over D equals 3/18. And I know what D is now because 2 over 12 is going to be equivalent to 3 to 18. Okay? But maybe I don't want to do times 6. Maybe I want to challenge myself. Well, maybe you can try to work up. That would be the next step, the next most challenging, because then I know that 18 divided by 6 equals 3. But the problem here is I don't know this value. So this value divided by 6 would equal 2. This is where your knowledge of equations comes in, right? It'd be like 18 divided by 6 equals 3, so D divided by 6 equals 2, right? Because I know 18 divided by 6 is 3, so D divided by 6 would equal 2, right? Well, I know how to solve this equation. I know that the inverse operation of division is multiplication, so I would just multiply by 6 here, multiply by 6 here, D equals 2 times 6, which is 12. We already knew that. Are we right? Absolutely. So that's wonderful. Also, horizontally, 2 times 1 1/2 equals 3. So I could say D times 1 1/2 equals 18. Well, even then, that's still kind of interesting, but 1 1/2 D equals 18. So I would have to divide by 1 1/2, wouldn't I? Divide by 1 1/2. This gives me 1D. 18 divided by 1 1/2. Well, that's 18 divided by 3/2. So I'm going to come over here. 18 divided by 3/2. So then I would multiply by the reciprocal. So I would say that's 18 over 1 times 2/3. That gives me, and I don't want to do that there, I don't want to make a string, 1 and 6. When I cross cancel, cross simplify, so I know 6 times 2 is 12 over 1, which equals 12. There I am again. I've gotten 12 3 different ways based on multiplicative reasoning with this relationship. Ratio boxes are very powerful. There are multiple ways. I mean, I didn't cover every single way that you could work with a relationship here, but I want you to push yourself. See the relationship. It's multiplication and division. Yes, you're going to have to use fractions. Yes, you might use decimals instead. Whatever you choose to use, I want you to be firm with it. I want you to work hard because you will persevere. This gets really cool because I haven't done this like this before, but proportional relationships can also be graphed on a two-dimensional plane. So we also call this the coordinate plane, right? So again, we have cats to dogs. For every 2 dogs, there are 3 cats. For every 3 cats, there are 2 dogs. Now I want you to notice, this is the same relationship here and here. All I've done is changed the order. The order makes a significant difference in how it is graphically represented. So here, if I have 2 dogs, I have 3 cats. If I have 4 dogs, I have 6 cats. If I have 6 dogs, I have 9 cats, and so on. Okay? This is, and I put this arrow here so I could just label it for you so you could see, that's 4 dogs, 6 cats. Okay? The relationship is maintained that 4 to 6 is equivalent to 2 to 3. The 6 to 4 is 3 to 2. Okay? And then here, if you notice, this one is steeper, and this one is what we would say is shallower as a graph. I want you to keep these in mind. We are going to work a lot with these in class, but I want you to have them in your notes. Here, cats to dogs is 3 to 2, and as a fractional representation, we would do 3/2. But again, this is 3 to 2. Dogs to cats, 2 to 3, It looks like 2/3, and that one is the less steep of the two. This one is steeper, this one not as steep. Interesting, right? Okay. Now, if you know the relationship between two quantities multiplicatively, then you can find any unknown value as long as one data point is available. So here again, same scenario, but we're just expanding. Thursday at the SPCA, there was only one dog. So how many cats would you expect to find? Well, here's my dogs and cats. I know it's 2 dogs for every 3 cats, but there's 1 dog. Well, to get from 2 to 1, I divide by 2. Could also say multiply by 1/2, right? Well, 3 divided by 2 is going to be 1 1/2. It's important here that depending on the scenario, that you answer reasonably. The answer 1 1/2 cats, not really appropriate, right? So while the mathematics is correct, this is when you must double check yourself to make sure your answer makes sense. And so you're not going to answer with 1 1/2 cats. Yes, the ratio and the proportional relationship mean that there should be 1 1/2 cats, but every once in a while that ratio is not going to be realistic. And so we want to be sure that we give an appropriate answer. And so a reasonable answer would be probably 2 cats. Okay, because 1 1/2, you would round up to 2. You would assume there are still going to be more cats than dogs, so 1 cat for 1 dog, not as appropriate as at least 2. Now that does change up the relationship, but we have to keep in mind sometimes real world scenarios don't always exactly fit mathematics as we would expect. So you want to be careful, okay? However, our next example does allow for fractional pieces. For every 2 inches of rain that fall in the Amazon rainforest, a young vine grows 3/4 of an inch. So how long does a young vine grow if it gets 16 inches of rain over 3 days? So here, I've got 2 inches of rain for every 3/4 of inches the vine grows. Or actually, the vine depends on the rain here, doesn't it? And so if it rains 2 inches, the vine grows 3/4 of an inch. But what if it rains 16 inches? Interesting. Well, this is where I haven't filled in any of the multiplicative relationships for you. So where you would have to figure it out. So the first one that I notice, and the first one I think you would notice, is how do I get from 2 to 16? Well, that's a times 8 relationship, right? So that's what I would label on my ratio box, times 8. So if I'm looking for this value here, 3/4 times 8 is going to give me that amount. So that's 3/4 times 8 over 1, and that's going to give me 24/4, which 24/4 is equivalent to 6 inches. Now that's a ton of rain. For every 2 inches is 3/4 of an inch. So that much rain, it is going to grow 6 inches. It's a reasonable answer, right? Okay, so there's your answer there. But what if there are 19 inches of rain? Do you know 2 times what equals 19? You do know how to solve an equation though, don't you? So what if I don't know 2 times what is 19? See, not every relationship that we have is going to be peachy. So you're going to have to find those relationships yourself. That is so okay, because you have all of the tools necessary to do that. 2 times what is 19? Times what? Well, that sounds like an unknown. 2 times what is 19? Well, I know that if I have 2 times something I don't know, I can write it like that. And I know that 2 times something is going to be 19 because I have a ratio relationship here, and I know it's multiplicative in nature. So if I want to know what x is, I divide by 2. I divide by 2. X is 19 halves, but 19 divided by 2, that's going to be 9 with 1/2, right? 9 and 1/2. Let me make sure. I'll do the math for you so you can see it. I know that's 9, that's 18. There's 1 left over, so it's 9 1/2, right? So this is no longer times what? I know that it's 9 1/2. So this is times 9 1/2. There. Now, should I be able to get x? Absolutely. If I know that 2 times 9 1/2 is 19, then 3/4 times 9 1/2 is going to get me x. So that's what we have to work with. So again, I'm going to use red because this marker's dying here. 3/4 times 9 1/2. So do you understand how important your fraction multiplication skills are here? 9 1/2, that's 18, 19 halves. We knew that already, actually. So 3/4 times 19 halves. 19 times 3, I'm not 100% familiar with that, so that's 57/8. 57/8. Well, I know that 56 divided by 8 is 7, and so that's going to be 7 1/8 inches. Now, just to wonder if that makes sense, well, we actually kind of have something to relate it to, right? 16 inches of rain made it grow 6 inches, so 19 inches of rain will make it grow more. I think that 7 1/8 inches seems pretty reasonable, right? So there you go. 7 1/8 would go right there. And that is how we are going to solve for unknowns with proportional reasoning, with ratios and multiplicative relationships.